Hi friends, so today I'm going to discussing about Maxwell equation and how this Maxwell equation going to help in electrodynamics. So let's start the video. So we have a Maxwell equation. Maxwell equation. Those are delta dot E is equals to rho by epsilon, first one. So second is delta cross E is equals to minus dou B by dou T, and third one is that delta dot D is equal to 0, and fourth is delta cross D is equal to mu naught into J plus mu naught into epsilon dou E by dou T. So how to remember this? There is a very simple trick, that is you need to remember. So you know the Gauss law. So what's the Gauss law? Surface integral of E dot ds, vector E dot ds is equals to q by epsilon. Replace this q by rho by epsilon. To remember this RHS sign, so the thing is LHS. So delta dot curl sorry gradient of is equal to rho by epsilon, and curl delta cross E, that is the curl of E, is equals to minus dou B by dou T. So how to remember this? So E is a electric field, B is a magnetic field. So curl is always equal to partial differentiation of magnetic field and with the negative sign. And with the third equation, that is the gradient of magnetic field is equal to 0. This is very simple. Gradient of magnetic field is equal to, so delta curl of magnetic field is equals to mu naught is a permeability of a free space, and J is the current density, plus mu naught into epsilon naught dou E by dou T. So this magnetic field, it is a sum between current density and electric field with the partial differentiate form. So this is same thing. Mu naught, both the side we have to write a mu naught, that is mu naught into J is the current density, addition with the current density, and we have to add a partial differentiation of electric field along with the epsilon into mu naught. So these are very easy to remember. So further, so we know that xi, xi of r comma t and j of r comma t are two functions. With this xi is function of r and t, and current density is also function of r and t. So further, we know that curl of electric field is 0. Curl of electric field is 0. This can be written as E is equals to minus delta dot D, gradient of potential. Electric field in terms of gradient of potential. So we can write it as, we know that B is equal to delta cross A. Okay, so delta cross A. You have to remember this thing. B is equal to delta cross A. Moving further, so remaining thing what? So I have a delta. So we have to substitute here. We have to substitute because we know that Maxwell second equation. We know that Maxwell's second equation, what it says? Delta cross E is equal to minus of dou B by dou T. But we have a B as a minus of dou by dou T. In terms of B, we have a delta cross A. Just substitute that. Okay. So moving further, what happens? What we have to do further is, Keep delta cross E as it is and take this to here. So what happened? Delta taking common cross vector E plus dou A vector divided by dou T, which is equal to 0. Just I am taking this term to the LHS side. Okay, taking a delta as a common. So we know that what we know, this delta cross E is equal to 0, but E is equals to minus of delta B. Just substitute over here. So remaining is vector E plus dou A vector divided by dou T, which is equals to minus of delta into V. Okay. So lastly, vector E is equals to this, we have to send in RHS side, so it will become delta dot V minus dou A vector upon dou T. So we have to remember this equation for an electric field in terms of a potential and area. So up to here our concept is clear. So for a next video, watch my part 2 video. Thanks for watching.